Welcome back to another Daishinfinity video. In this video, we're going to prove the logical theorem, which is in idempotence identity theorem or identity law. In other words, in tautology. So it's just something we need to know in mathematics, something trivial we need to understand and comprehend in mathematics so that we can actually prove many other theorems, since this is somehow the main thing we have to understand, such that we understand the logic of mathematics. So in this video, I'm going to try and prove this to you guys. First of all, let's try and prove the idempotence. So the idempotence law or theorem states that for any statement A, and if you have another statement which is the same statement A, and if you combine it with this symbol, it means that it's also A. In other words, if we have A and if we have this symbol and combine it with A, it also equals A. Okay, so what we have to prove is that those two formulas actually work. So let's prove A and A. A and A means that both of the statements should be right. And if it's right or true, if both of the statements are true, then the statement is true. And if one of them is false, then it's false. Okay, so let's write it in a table. So we have A, and A, and A. It's actually very simple. A can either be true or false. So if we take the combination of A and A, then both of them have to be true, such that the statement is true. So we can say the statement is true here and the statement is false here, because both of them are false. So now we see the same thing here and here, which is A. So that's why it's congruent to A. Okay, very simple. Let's try and prove A or A is equal to A. A or A is equal to A. So let's just, sorry, what have I done? So let's write the table here. A and A and A or A. So A can either be true or false. So if we take or as a combination, then one of the statements should be true such that everything is true. So both of them are true, so it's true, and none of them is true, so it's false. So we see over here the same thing, true, false, and true, false, since A is the right side of the equation, such that we had to prove this formula. Okay, so we have proven both the idempotence. Now I'm going to try and prove you guys, or show you guys, what the identity law looks like. So for any statement A and a true statement, it's also it's always the statement itself. And if we have A as a statement or a false statement, then it's always the statement itself. So let's say true is a statement, and let's call it T, and let's call false a statement, which we call F, big F. So if we have A and the true statement, which is true for everything, then we can prove that it's A afterwards. So A can either be true or false, and true can always be true, can only be true. Then if we take A and true, Then we see that both of them have to be true such that the statement is true. So this is always false since one of them is false already. And we can now see if we take A and false as a statement. I'm just going to continue my table. Then the false statement is always false for everything. And if we combine it with A or false, then either of them should be true such that everything is true. So this is true since one is true. And since here both of them are false, it's false. And now we see if we compare it to A again, which can be true or false, we see that A and true and A or false is always congruent or equal to or equivalent to saying it's the statement A itself. So this is the identity law. Now for the last part, let's try and prove the tautology. The tautology states that if you have a statement A and you have a negation of A, then it's always the true statement. And if we have A and we combine it with an and negation of A, it's always a false statement. Okay, so let's try and prove those two by writing a table again. And then we can see, or afterwards we will see that it's actually not possible that the first statement or the first formula is equal to false and the second is equal to true. It should be true first and the false for the second formula. So let's take A here, negation of A here, the true statement here, and the false statement here. Then combine A or not A and A and not A to show the formulas afterwards. So A can be true or false. Not A is the negation of A. So for every true statement, it's a false statement. And for every false statement, it's a true statement. Then the true statement is true for everything. And false is false for everything. Let's see A or not A, which means one should be true such that everything is true. So we see this is true and this is true. And this should be false and this should be false too. Since if we have A and not A and these are both statements, like one of them should be false, that everything is false. And you see one of them is false, so everything is false. Okay, so we see A or not A is equivalent to saying it's true, and A and not A is equivalent to saying false. So we have just proven every formula, and I really hope you guys enjoyed this video. Please like and subscribe, and I think this will be the last Daishinfinity video of this year, so please like and sub, and we will see us in 2026. See ya.